Okay, so what we are gonna do today is we will just quickly see how a machine learning practitioner views a problem and how the problem is machine learning problems, how the machine learning problems are different from normal problems, and we'll see what models like as we seen we use models, different models for solving problems, machine learning problems. There are different models for different type of problems, but what actually a model consists of and how we can think of a model. So we will discuss about that. So yeah, just a moment. Yeah, I hope my screen is visible now and you can see the PPT. Just type in the chat box so I can see. Yeah. Okay. So in normal problems, we can say traditional programming, what happens is there is a problem and someone in charge of solving this problem analyzes the problem first, writes the code to solve that problem, and then the program which he writes does the work. Okay. So what generally happens is any coder, or we can say any programmer, what they approach is they first analyze the problem, they write a solution by themselves in code, and then that written code is used to handle that problem. Okay, but how machine learning problem solving is quite different. Here we give computer some data to analyze problem by itself. We also expect computer to write the code, like not actually write the code, but to figure out how to solve that problem. And then we expect it to also work when we want to solve that problem, like all the things it should do by itself. Okay, so like what happens is there is a model, we just write a code, we just write a step-by-step algorithm, like we tell what computer has to do, we just specify generic steps, like we do not specify specific steps for each model. We just have general categories of models, like regression models and like classification models. Okay. I think there is a code. Just a moment, guys. Okay, so am I audible clearly now? So we were talking about that there is a program, we write a code, but we do not write a code specific for a single task. We write a code for a general category. Like there are some types of problems, right? We saw that yesterday, like classifying things and predicting some values. So accordingly, we have different categories of models. We have different types of models, and we use those models to perform in all scenarios. Like we use the same model for predicting, for identifying cat and dog. We use the same model for identifying man and woman. So the same model can be used for both these tasks. Here the tasks are different. In one we are using it for classifying cats and dogs. At other place we we are using that model to classify men and women. Okay, so what is the difference here? The difference is in the data we give it. Okay, the model is basically the same. The same model can do both the tasks, but the model, if one time we provide data of men and women to the model, then that model becomes specific for classifying men and women. That the same model has what we can say adopted some techniques to classify men and women using that data which we fed it. Now that particular model, now it cannot differentiate between cat and dog because we haven't trained it to do that. We only trained it to classify men from women. Okay, so if you want to use the same model, if you want to classify the cats and dogs now, so we have to take the general model which we have, which we had before training it, right? Which we have before feeding the data. We have a generic model. We feed the data, and then that model becomes specific according to the task. Okay. So here, what happens is we feed the data to the algorithm. This is a learning algorithm. This learning algorithm and the model are two, what you can say, are two like general. They are not specific according to the task. They are in general. When the data is fed to it, the training algorithm helps the model to adopt the requirement. Okay, it helps to adopt the model. It helps the model to adopt classifying men from women. So at the time of data is fed, then the model becomes specific. So there is feeding of data, then there is a training algorithm. There is a training algorithm and there is a model. They are two different things. Okay. So once we fed this data, the training algorithm, what it does is it tells model that these things need to be changed. Like slowly, it one by one, it sees the images. In case of classifying men and women, it sees the data and tells model that just remember this thing, like just make this changes little bit in the model so you can adopt this task. Okay, classifying men and women. And similarly, after this training period, when we have fed the data and now models have trained the same model, we are using the same model. It has adopted the task. Okay, now after adopting the task, that model can be used for like a later purpose. Like after we are trained, now it is ready. Now we can use. Okay, so that is the step in machine learning, and we have seen how traditional programming is done. Like people analyze the problem, they write code by themselves, and then they use the same program. Here we write the code, but we only write the code for model and training algorithm, and then adopting the task, it is done by computer itself. Okay, so next thing, how we can see the process of learning this, like how the model is like how model adopts the requirements, like how it is before it was not trained, like before feeding the data, it was not capable of identifying anything. Okay, but then as we feed the data, he slowly adopts the techniques. So after that, we can use that model, and now it has become to classify certain things. Like in case of men and women, it can now classify after feeding the data. So what we can we have this analogy, like to understand the model and the training, like how the all the tasks are being carried out. We have a generic model. Okay, the first image is of generic model. For example, when we have to make a keyboard, what we have in the hand, we only have the sand. Okay, then we take this, we take that sand and try to make certain changes, right? We try to make certain changes. We do changes until we get the required until we get the required output. We mold the sand until we get a specific teapot which we have in our mind, right? In this process, we only have in mind we need this kind of teapot. Okay, so what we will do is slowly mold the sand and try to make the molded sand look more like this image. Okay, so here what we can compare is, this is our model. We speak now I have used regression model, I have used classification model. We can think of the model as a raw material. We have the sand. Now what training algorithm does is, it helps to adopt the shape of the model. It helps in changing its certain parameters. Everything is based on parameters. So training algorithm helps maintain that parameter, so that after training, the same can look more like code. The model which was at first generic, now it can have the capability of serving the purpose. Here we want a teapot to serve tea, right? So after training the model, after applying training algorithm, what it does is slowly changes the model. It changes the parameter of the model. Okay. Then we train it until we get the desired shape. We train it until we get the desired parameter. Here the parameter needs to be changed, and those are the reason behind giving this output. What we say while training the algorithm is, we are just changing the parameters. Okay. So if you have any background in mathematics, then you can think of it as a line of equation. When you change the parameter like x1 and y2, then you can get a different kind of lines. Okay, we'll see this. Here is the model. This is generic model, and here the comparison is between linear model. Linear model is basically a equation of line. If you have studied in mathematics, it is the equation of line. Y is equal to mx plus c. So here m and c are the parameters. X is the variable and y is the output. Okay. If you can't get it, it's okay. You can understand it like this. These dots are the data, all right, and this line is representing a model. This is linear line. That's why we call it linear regression model. Okay. These data points can be of anything. It can be images of men and women. It can be images of cats and dogs, or it can be images of or number of students or number of cities, people. Okay, so it doesn't matter what kind of data we are feeding at first. The model is a generic, so without data it is nothing. Okay, so after feeding the data, the model becomes specific. That we have to understand today. Okay, so is there any doubt what actually the model is? We have seen the analogy. Did you understand that analogy? How the model is only useful when there are data. So without data, the model is nothing. We cannot use that model. The model, with the help of data and learning algorithm, it adapts to the requirement scenario. It can be any scenario, classifying cats and dogs, classifying men and women, and then it adopts that task. He understands that now I can segregate this task according to the data. It understands. How it actually understands, it is all mathematics. So we will not dive into that. It just learns through data. Okay. Kind of molding clay. Yeah, it is kind of molding clay. So that was an analogy. So today we will not cover much of machine learning theory, and we will today, what I was thinking is we will start with Python now. Tushar is today he is not available, so I think if it's okay with you all, then we can move on to the Python background, and we can learn new libraries there, because they are going to be useful when we implement these models in actual code. Okay, so are you ready with your Colab setup? So you can type yes, so we can move on and start our Python journey where we left off yesterday. Yes, okay. So I think, yeah, we can start now. Okay. So just a minute. Yeah. All right. So can you see my Colab? Are you ready with your Colab? All right. Okay. Now we can start. So yesterday we seen some loops and conditions inside the loops, right? We seen for loop, we seen while loops. Okay. Is there any doubt in loops or conditions which we seen yesterday? If you have doubts, we can solve them first and then move on. No. Okay. Anyone else having any doubt? Then please ask now. All right. I think nobody has doubt. And if you have doubt later on into this today's session, then you can interrupt me. You can solve your doubts at the end. I will wait. I will give 10-15 minutes to doubt solving, because we are gonna start something new, little bit not difficult, I would say, but little bit more content. Like there would be bunch of stuff which will be new today. So before that, we have for loop, we have completed for loop, we have completed while loop, we have seen statements. Okay, functions we will do later on. I think it is not required now. We can see dictionaries. Okay, so all right, we can now move on to dictionaries. Dictionaries are data types. As we seen, data types like lists, we have seen sets, we have seen list. Okay, we have seen integers and all, right? You remember all those things? This dictionaries is also a type of data type. Okay, here there is some difference in representing the data. So like if we see list was like, you can see my font size, right? Or should I increase this? Okay, I think now it's visible. Okay, we have list like this. We have like we separate elements by comma. Okay, so here what we are doing is we are just giving the list of elements or bunch of elements and giving it a square bracket, and we are calling it a list. Okay, so this is just a way of representing an object, like a bunch of elements together. Okay, and now how dictionary is different is it has a key value pair. Like if you consider like simple variable like name equals okay, we can give any name to Tushar. All right, so we know that like how we can store this string in this variable. Okay, we are clear with this concept of variable, values, and assignment. Okay, so now dictionaries help us to store bunch of things together in form of key and values. You can see this syntax here. Okay, this is the syntax. Okay, we use curly braces here. Remember, we use square braces for list, round braces for tuples, and curly braces for dictionary. And in dictionary, there are key value pairs. And between all key value pairs, there is comma separated, like all the pairs are between my dictionary equals curly braces, then name, colon, value of that key, let's see, Smith, then comma, like now it is another item like salary, then we can give numerical values as well, like 0 rupees. Okay, I do not have any salary now, so okay, you can see this, like we have keys and values. All keys and values are in pairs, so one pair can be referred to as an item of a dictionary. Okay, and we can refer to as this first up as key and this one is value. So this is an example, like first name Smith, contact number 123, address Delhi. Okay, problem. Like this is just a way of representing values. Like we use here only name and all, right? But if we have many more items like which are related, like if I say I am a employee, okay. This let's consider this is a dictionary of an employee. So we can employee one, all right. We can store the related information about the employee in this type of structure, like employee has name, employee has salary. We can add address as well. Okay, and just remember the syntax are same. When you want to specify a string, then you have to use quotation marks, and else you can for numbers you can use directly. Okay, we store these dictionary structures are useful when we want to store related information. Okay, so this is about employee one. Similarly, we can have multiple dictionaries of different employees. Okay, so now we will see what things we can do with this dictionary data structure. Okay, data type. So we have specified employee one. Okay, invalid syntax. All right. Just a minute. I have used equal to, but we do not use equal to in the inside the dictionary. We use colon. Okay, remember that. We use only assignment operator here. Right. So let's run this and okay. Let's see what we can do. As we have mentioned, these are the keys. Salary, name, and address are the keys, and Smith, 0, and Delhi are the values. Okay, so we can read those things using this bunch of operations. You can see here keys, values, and items. Okay, so let's see. Employees one dot keys will return all the key values, the name, the salary, and address. Okay. Okay. Here it's keys, not key, plural. All right. So here it shows me all the keys that are in this dictionary. This dictionary can be like very big. Okay, I can add many items in this list in this dictionary, and there can be a lot of information about this employee, right? So if we want to see that what kind of information are there, we can use keys, so we can understand that it contains name, salary, address, etc. Okay, and don't concern about this thing. You will see like this is another data type which this is not that important. Okay, we will see what it does and how we can use those things. Okay, we will see that later. Okay, just see now what operations we can do. You can perform this as well. Employee one dot values. So now we can see all the values which are stored in this. Okay, so if you want only values, we do not hold the structure, then we can use dot values, and it will give us all the values stored in this. Okay, name, address, and all. And at last, if you want all the if we have specified right now only, so we can see that all this information are there. But if the dictionary is already stored and we want to see what all the things are there inside it, so we can use employee dot items. So we can see what items are there inside it. Okay, it will return all the pairs. What happened? Employee 1. Okay. Yeah, you can see now. This is a different structure again. What you are seeing is, we have seen it, right? And this type of structure is called tuple, where there is a round braces. So it returns the values in little different format. So it returns the list of tuples. You can see this whole is a list. Okay, and inside that list there are tuples which are containing values and keys. Okay, so we can see what things are there. If we haven't made that dictionary now, or someone else did that, and now we want to see what is there inside it, so we can use items. Okay, and about this list, what we can do is, I haven't written in here, but there are a bunch of different operations also. If you want to see, we have seen that by using values, we see all the values. Okay, but if I want to see any particular value, if I only want to see employee's name, so employee 1 dot note dot, we can use this notation, square bracket, and then we can specify key. For this, we should be knowing the key that we can know from using keys. Okay, so if I am unknown of this employee, I do not know what is all this information is stored there. So I can first see what is the key, what data is stored for him. So I can see name, salary, and address and all. But now I only want to see his name. Okay, so I can use this employee then name. Okay, so we can see it returns Smith. Okay, so similarly we can see everything about employees, like employee 1, then his address. But remember, we use this values should match inside this keys. It should be one of the key. Okay, so then only we will get the output. It matches the key with the key that is present in that dictionary, and then only it will show the output. Okay, so if there is no there are only name, salary, and address, right? So if I want to add contact number of this employee inside the list, then I can do employee 1, then in this bracket we can add contact number directly. I can specify the name here. It will be key and equals 1, 2, 3. Okay, so it will add this key and value inside that employee 1 details in the dictionary. So if I print dictionary now, employee 1, then this values will be added in the pair. Okay, you can see now contact number and 1, 2, 3. So we can add any value by like this, and if I want to delete employee 1, and if I want to delete his salary, okay, salary, then we can do that as well. Delete employee 1 salary. So these are the only useful functions for us. Now we can see what keys and values are. Okay, there is doubt. Does it get arranged in alphabetical order? Yes, it gets automatically arranged for us. So like when we are seeing, it does actually search in the background, right? When we search, like when we perform this task. Okay, so it is for the betterment of the computer that in the background it searches and it gives us. So it automatically arranges. But this is not the case all the time. Like I have mentioned this. Like this is also an unpaired, what we say, unordered items. Okay, so if I have added anything with anything which starts with from B, then it will be added here. Okay, so it cannot be iterated. It can only be accessed like this. We have to specify key value and we can see what is there inside it. Why is it not, if the one is not specified? Okay. So here we have deleted salary, and now if we see what is there inside answer one, then it will be deleted. So these are the useful operations for dictionary now, and these operations and the way we write data and see the data inside dictionary will be useful when we see Pandas and series and all. So I think till here it's clear. We have seen how we represent data in dictionary and how we see what it contains and how we add and delete items inside the dictionary. Is there any doubt till now? You can write it in the chat box or you can unmute. Yep. Alphabetical while displaying no doubts. Okay. If there is any doubt, you can definitely unmute and speak, or you can write in the chat box. Okay. So let's move further. So now we have Pandas. So now this will get a little step up. Then I will try to make it relatable with what we have done till now. Okay. So Pandas, what Pandas is, it is a collection of functions. See, what we are doing here, print, okay, and we are specifying something like Smith, okay. So it prints for us, but what actually it is, like what does this mean? This is a function, okay. This is a function, okay. So there are many other functions as well, like we can use input, okay, input function, and like enter some value, okay. So it will be ask us for inputting value. We can give any values to. All right. Then we can also assign these values, like value equals input. But what the point is, like there are a bunch of operations, like there are many operations or functions, we can say, which are already defined somewhere, okay, in this like in the background. It is stored already in the background, so we can use them directly by print. Okay, let's see functions first. Actually, it will be more clear. It's easy, not that difficult. Functions are, let's see why we use function first. Okay, so just for example, I have to print name of people. Okay, so there are person one equals let's say Smith. Okay, and let's say we have already seen for loop, right? For loop and list, so we will use that. Okay, my list equals name of some people, Smith, then Tushar, then who was there? Aditya. Okay, Aditya, then a few more, Akash. Okay. So what we are doing here is we want we want to print these names. Okay, so we have seen that we can use for loop for names in my list and print these names. Okay. Okay. So we have seen that doing same thing again and again, we can use for loop. Okay. But there is another way of doing these things. Like there is another way of doing same thing again and again. So here we can see we can do this task. But what happens is if there are different files, there are many files. We have this file named Bootcamp. Okay, so there may be another file on my computer, and at that place in that file, I have written a program to add two numbers. Okay, we will see functions like this. Define. Okay, add. We want to add two numbers, a plus b. Okay, so what we can do is specify values of a equals to 10. Okay, then b equals 2, let's say, and then we want to print the sum of these two. All right. Okay, so now I have written this statement which does the sum and prints it. Okay, but now what I have done here is I have given the values. Okay, 10 and 2. But what if I have to do for different numbers which are not actually defined? Like if I want to use this again and again, so I would in any files I can say if I have written this summation code in this file, and if I want to write in another file, if I want to use it in another file, so I have to write it again in another file. Okay, so instead of doing that, instead of writing every code in all the files, what we can do is we can define a function. Okay, this is just a structure of function which we have defined def as a key. Then function name, we can use any function name. Then we have round braces, we have parameters, and this colon as well, and indentation and statements. So there are multiple things, but if you see one by one, there is just only this defined word we have to remember, and then we can name it my function. Okay, I'm writing an example so you can understand quickly. Okay, and here this is optional. Okay, this is optional. And here I have statement like print Smith. Okay, let's consider that there is something I want to print this Smith for 10 times. Okay, or if I want to print a name, let's not be very specific. I want to print a name. Okay. And what I will do is I have different names. What is it? Okay, we have defined here, right? Names in my list. Okay. Just a moment. What is happening here? All right. Name equals my list. Okay. So now the name in my list are same. Okay. So what I want to do is I want to print a name, but it can change every time. Okay. So greet. This is the best example I can give. Okay. Greet. Then name. Print. Welcome. And then this name. Okay. All right. Yeah. Okay. Now I think we are ready to. Okay. So what I want to do is just forget about this. So here, what we have done is we have described something like we have to greet. Okay, we have written this print statement. We want to greet all the people the same way. Okay, welcome. Then we want to greet multiple people. Okay, so just let's consider. See, I want to greet me. Okay, okay. So what I'm telling. Sorry. Okay, just a moment. Okay. If I want to greet multiple people, okay, one by one, and those names could be different. So what I would what I will have to do is print hello Smith, okay, then print hello Akash, etc. Okay, so what I will have to do is I will have to write this print statement multiple times for different people. Okay, so instead of doing that, instead of writing whole print statement, what I will do is I will make a function of greeting. So like we are defining or we are telling computer only one time that how to greet, and then we are just asking the computer to greet. Okay, hello times n. User-defined function. Yeah, user-defined function. These functions are user-defined functions. What we are going to write, and what we are using that print and all, that are predefined functions. I didn't get you hello times n. Okay. If you want to print n times hello, yeah, that can be done, but it does test. In that case, the for loop is more preferable because we are printing the same thing. Okay, and we are not changing anything. Hello times n. Okay. But here, in case we have some task which is same all the time, and all the time we have to tell computer that we have to write the code for it that do this task. But if somehow we can tell computer, tell computer one time that when I tell you to do this, just do these things. Okay. So here what we are doing is we are telling computer how to greet. Okay, so we are telling that how to greet, and we are telling them when I ask you to greet, just print welcome and then whatever the name I will tell you. Okay, so let's see an example. If I greet, what I am telling is greet Smith. Okay, Smith. Only this round braces. Okay. Oh, there is problem. Yeah. Okay. So now what is happening here is we are just telling computer to greet. Here now I can use this greet anywhere in my code. I can use anywhere like greet, and then I will tell him greet to whom, like okay, Akash. Then it will greet Akash for us. So what we are doing actually here is we are just telling computer one time, like when I ask you to do something, then what you have to do. Okay. So we have named this function as greet. So we can understand that we are asking to greet people. Like similarly, we can create any function. Like let's see another example. Definition. Okay. Then sum. When we tell computer to sum, okay, then what it should do is a comma b. I will tell you what is there inside this and why we have name written name. Okay, just print a plus b. Okay. So what it will do is we have told computer here that when I tell you to sum, what you have to do is just print a plus b, and this a and b I will tell you. What we are doing is just print name, and here this name I will tell you when I call you to do something. Okay. So here this is a variable. Okay, a placeholder, and this is a formatted string. Okay, we will see this, and what we are doing is how it is different than normal string is when we write something in these braces, so this is hard coded string. Okay, this is a string. But when we want something in between, so how we can do is we can add this variable. Okay, we can add here like welcome to show. Okay, so here when we want something to change in between, at that time we can use this curly braces and this f. These are called formatted string. So this is the normal string and this is a formatted string. Okay, so here this f, after writing this f, it gives us the capability of writing something variable that can change at times. So we can use this type of syntax for this, and we can we have to specify actually that what will be there. This is just curly braces are just placeholder. Like we are telling that at this place, just replace it with the name which is passed at the time of execution. Okay. So what we are doing here is we are defining this and telling computer that you have to greet people, and how you have to greet, you have to do this task. Okay, and we are naming it. This is a placeholder that we will give you some name, and you have to make use of it and greet the people. Okay. Similarly, you have to sum when I ask you to sum, and what you have to do is you have to print A and B. Like I will give you A and B, and you have to make use of it and print, then add them and print. Okay. So we can use later on that sum 1, 5. Okay. So it will add it for us. Okay. We don't have to write any plus or like we don't have to write A plus B or every time numbers. Okay. So we can use this stuff again and again. Just we have to call it. Like just we have to tell computer that do this task, and we have to give these values as well, which we specify here in the round braces. Okay. So is this understood, the function? Is there any doubt inside these functions? If you haven't understood anything, like what we are doing inside this round braces, these are called parameters. Okay. So we pass parameters at this time, we call it, and here we write any variable like AB or something placeholder which specify that there will be some value. Okay. Yes, clear. Okay. In Python we don't do curly braces. Correct. We do curly braces. I didn't get your question. What I asked you can unmute and ask. We use same type of syntax. Like we can use curly braces, and its meaning is also different. Like in English, we have words whose meanings are different in different contexts. Okay, so we have to remember the context, like where we are using that. Okay. It's clear.
No, what I'm actually asking is like when we declared the function, after that we didn't like contain it enough curly braces, right? In C++ that we're learning right now, when we define a function, it's inside curly braces. Here there were no curly braces when you were defining a function. So I was asking, in Python we don't have the curly braces after we define a function.
Okay, I got your questions. Like I think you are coming from C++ background, right? C or C++ background. So what is different in Python is in C++ we use curly braces differentiating between different code blocks. Okay, like for an example, in C++, what we like int. Okay, if you don't understand this, don't worry. This is for those people who are coming from different language. Okay, my function. Then we have parameters, and then we have this type of syntax. And here we write our statement like print. Okay, print something. Alright. So what is different in Python is they have get rid of this curly braces. Okay. how Python understands these things is by indentation. If you have attended the first 2 lectures, I have mentioned that do take care of this indentation. This indentation is very important in Python. Okay, you can see it. I have highlighted by this indentation, so Python can understand that this print statement is inside this statement. Okay, now here is definition. This is a function, and what we are doing here, it is inside this function. We have seen this in here. You can see this while loop. What we are doing is this column, and then the next line we are writing one step inside it. Okay, so by giving some space before it, the Python can interpret that these 2 lines of code are inside this loop. So what in C and C++ the compiler understand is when there is a curly braces, it understands that inside those curly braces, whatever statements are there, that are inside this function or inside this condition or inside the loop. Okay, so here that is the difference between curly braces and indentation. So Python has replaced curly braces and introduced the concept of indentation. Okay, so I think your doubt is clear for container. Okay, yes, clear for container functions. Oh, I see. Yeah, all right. So now we can move on, and we have seen functions. I think there is no doubt in function side. If you have any doubt, you can write in chat box. I will try to clear it. And okay, in dictionary, all right. So now we can move further on pandas. Okay, let's see what pandas are. Pandas is just a name given to a collection of functions. Okay, like as we defined here our own function by giving what we have to print. Okay, we don't need to see how this print statement is showing the output here. What is going on background? We don't have to see those stuff. Okay, so this is important when we don't have to write the same thing again and again in multiple places. So we use functions at this time, and pandas is just a collection of functions. Those type of functions. We will see what type of function it has, and we will see what functionality it has. Okay, so let's first see what are the concepts of pandas, like why pandas, why someone written those functions in pandas. Okay, first of all, there are 2 data types again. Okay, this here there are 2 types of structure. There are 2 types of structure: series and data frame. This is new. Like you can, I will help you relate these things to what we have already done. So you can relate this series as this. Just see only one this row. Okay, the data row. Only consider this data row. This is a series. We can refer this type of structure by many names. Like we also use vector name for this. In pandas, whoever written the pandas functions and all, he referred it as a series of elements, we can say, or series of data. Okay, this one column is known as series, like a list of values or list of elements, whatever we can assume of. Okay, so one line of data is known as series, and similarly we also had such structure in list as well. Okay, but did you remember, like at that time we were having another thing. What was that? Index values. Okay, we were having 0, 1, 2, 3, 4, all of these boxes. Okay, we had index values for all of these items inside this structure. Okay, similarly, pandas series also has index. But if you have remember, I told you that in array, in list, the index is only 0, 1 and all. Okay, we don't use any alphabet or anything else for naming the index. Okay, it is by default 0, 1, 2, 3, and we cannot change that. But here, this structure also has index, but we have a facility to name it according to ourselves. This structure will always have index, and we have facility to name it according to ourselves. Okay. Here in this example, the index values are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay. So it doesn't matter like what we are indexing, but one property index is that it should be different. Okay. Like here, if there is Monday, then the Monday cannot be repeated here. Index are what we can say discrete values. Okay. So we cannot repeat those values again and again. Whatever is here inside the index. Okay. So just remember, this is the structure of representing data. We call it series, and it has index. We can name index according to our requirement, and by default, it has index similar to list, like 0, 1, 2. By default, it also has 0, 1, 2, 3, like a similar index as list. But we can also change if you want. Okay, there is some, so we define index and corresponding data. Yeah, we can define index as well as corresponding data. Yeah, we can define both the things. Like we have full facility to do anything with it. Okay, so we will see how we write data in series, how we can create a series of data. Okay, so there is series. Okay, it is like array. If you have studied in any other programming language like C, we use name list for this type of structure in Python. In C++ and other programming language, it uses array. Okay, so it is similar to list as I mentioned, and it is homogeneous. So now here it is. There is some difference. Okay, what is this? Yep, series allow number index and stuff. Yeah, we can give value in index according to our requirements. We can change this index. Yeah, we can use numbers as well. We can use any non-number values as well. But by default, it is numerical, 0, 1, 2, similar to this. Okay. I was telling it is homogeneous. What homogeneous does mean is we can use only similar type of values in this. Like if I have this data, this one structure, then if there is number, then all the numbers, all the elements should be number. It cannot contain like first number, then string and something else. Okay, so someone who is from another background, they can understand that in other programming language, this is the rule. Okay, all the data type, all the elements should be of same data type. Okay, here it is of numbers. Okay, so homogeneous means similar values. Okay, if it is of string, then similar values. Like then there can be there cannot be any number. Okay, so it has index as I mentioned, default numerical, and we can change according to our requirements. Okay, how we create this series? Okay, we can create this series from lists and dictionary. Okay, and there are NumPy arrays as well, but we will not cover NumPy today. See how we can create this series from list. Okay, so let's create our list. List 1 equals. Remember, you have to create a list homogeneous values. Okay, 1, 2, 3, 4, 5. Okay, this is my list. And if I write what is the type of this list 1, then it will show me that list. It is a list type. Okay. Now, if I want to convert, first of all, when we want to use Pandas, so as I mentioned, Pandas is just a collection of functions which was written by someone else. It is not core facility of Python. Okay, this is extension of Python. So some Python was created first, and then someone used that Python basic concept which we see till now, and using that, it he or she, I don't know, they created new functions, like new functionality, so we can other people can use. Okay, so those are not basic core concept of Python. Pandas is not a core language of Python. Okay, when we use core functions like print and input, we can use it directly. But as I mentioned, it was written by someone else. Then it has to be imported. Like it has to be called first. Like wherever it is written. Now this all functions which we use till now was in the core Python. Okay, so when we install the Python, like in Colab, it is already installed there, so we don't have to do that. But when we install in our computer, when we install Python, it installs all this functionality, all these functions, which are in core Python. But now Pandas is extension. It is a library of functions, which is a collection of functions. Okay, so we have to import Pandas. Okay, so import Pandas. Okay, once we import the Pandas, then we can use it. Then we can use all the functions someone written. Okay, in those files. Now, when we import these files, now Python interpreter knows that when we use any function from Pandas, it has to look in those files. Okay, new files. Now, if I import Pandas only, then I have to refer this Pandas. Like if I want to create any series, I want to create a series. Okay, so I will have to use Pandas dot series. Remember, this is capital. First S is capital, and I have to pass a list one which I have created earlier. So what it will do is it will create a series from this given list. Okay, so we can create a series like this. It has created a series. These are the values, okay, which we gave 1, 2, 3, 4, 5, and this 0, 1, 2, 3, 4 are the default index. As I mentioned, by default it is numerical values in index. But here, one thing we have to see is we have used Pandas. We don't when we want to use any functions, this is a function of Pandas library. Okay, from a collection, it is one of the function Pandas, and it is inside this Pandas file. Okay, so I don't like to use this Pandas all the time. Okay, because whenever I want to use those functions again and again, I will have to write this Pandas as first word, and then I can use those functions like series. Okay, so what I will do is I will import Pandas as PD. Okay, what it does is it just helps us to refer this Pandas by just writing PND. Okay, so it is kind of in English like import Pandas as PD. So now instead of Pandas, we can use PD, and it will work. Okay, so this is just a nomenclature. Like for our simplicity, we use Pandas. Okay, PD series because I haven't run this. Okay, yeah. Now it works as same as writing pandas.series. Okay, so now we can use all the functionalities of Pandas. So there is a series. This is how we create a series. We can create it from list. We can create it from other data structure like tuple. We can create it from dictionary as well. So let's see series. Let's first define dictionary. Equals name and let's say roll number, R number 1. Okay, so and this is our list dictionary. Then okay, understood. Okay, so similarly we can write this my dictionary in this PD dot series. So it will do the task for us. Then there are different type of objects. Here you can see dictionary. One thing I have to mention is when we have list, it uses the default index values. Okay, like 0, 1, 2, 3. It always has index values. Okay, but when I convert a dictionary to series, what we had keys and values, right? So the values will be stored as data, and these keys will be used as a index values by default. When we convert a dictionary into series, Pandas series, then it will by default use key values as the index values. Here you can see these are key values, and here these are data values. Okay, and here it was by default numerical. All right. So similar to this series, let's come here. Similar to this series, we have single line of data, right? We can now this is a series. Okay. Now we can see data frame. Data frame is just a name. You can remember like data frame is a table. Okay. And similarly, it also has index. What is the difference is it consists of multiple series. Okay, this is one series. You can see my cursor. This is one series. This is Tokyo is another series. Paris is another series. Mumbai is another series. Dates is also another series. And it also has index similar to series. Okay, so this table kind of structure is known as data frame. The one person who writes this data Pandas referred this table as a data frame. It gave the table a name called data frame. Okay, so how we can use this data frame? Okay, so this is data frames are simply multiple series. Okay, or what we can say multiple list and anything we can consider. Okay, so now how we use this data frame? I think it's not getting boring today because we started earlier today. So are you guys like enjoying, or what should I do? Because there are more couple of functions there for it, or we can start it later on as well according to your wish. Okay. Index corresponding data. I'm not okay. What is meaning of PD, or it's just abbreviation? Yeah, it is just abbreviation. Okay, just not right. It's interesting. Okay, sure. We will move on. It's 7:40 now. We can do it for 10 more minutes, and then if there is any doubt, then we can solve this and solve the doubts. Okay. So just first we can we can see the background of this data frame, like why these data frames are needed, like why someone wrote those many functions for this data frames. Okay, so as we know, we use Excel, right? This is similar, not similar, I would say this is same as Excel sheet. Okay, sheet. Then what we have, like we also have this table heading. Okay, date, Tokyo, Paris, and all. And what in here data frame, we call it as column. All these are columns. Okay, we know. We call it column names. Okay, column names. This is column names. This is data, and there is the index. Data frame consists of three things: index, column names, and data. All right. And why it was needed is, as you all might know, that in business there are a lot of data, and all those data are, if they are structured data, then all kind of data are stored in this format. Okay, tables. Almost all the industry, all the companies store their data like this in tables. They use Excel, or there are CSV files as well. CSV file, if you heard before, this is CSV files is a way of storing this table inside a normal text document. Okay, what a normal text document is consists of, we cannot draw table in doc, right? I'm not talking about Microsoft document. I'm talking about normal document file, like WordPad. Okay, not WordPad actually. WordPad, not Notepad. There are different. No, Notepad is a different thing and WordPad is different thing. Notepad we can code that. Okay, text file. Yeah, we can like use this word text file in normal text. How we can represent this table in normal text? So CSV is just a format of writing of representing this tabular data in a text format. Okay, so you can read on that further, but just remember whenever we refer CSV file, then just remember it is a table file. Okay, the CSV file consists of this kind of tables. Okay, if someone is telling that I will give you data in CSV format, then they will give you a table of data. Okay, comma separated values files. Yeah, correct, Akash. Then if now like we are starting with machine learning, right? So this is a machine learning bootcamp. So we will deal with data. So all those data will be in this format only. Okay. So here we have like just consider. Okay. And these are dates. Okay. First, and there is dates, and these are the temperatures in the different cities like Tokyo, Paris, and Mumbai. And this, let's consider these are the temperatures. Okay. Now this is the data, and if you want to predict that at what time of season or on which month or on what date, what is the probability of like coldness, or what would be the temperature if you want to predict, like okay, forecast, if you want to forecast that what will be the temperature tomorrow. So we will be dealing with such data in such format. Okay, now here we cannot use data directly because this data can be in anything, like it cannot be a true data, right? Because see, here in this example it is a formatted, and I guess it is a correct data, but in businesses there are lot of times where there is data, but all those data are not useful. Okay, there may be some errors in data, like some human errors, like if someone is entering data and by mistake it entered some other values. Well, so there are mistakes as well, and then there are if we are considering temperatures, okay, and if we have some sensor, okay, let's consider this data is generated through sensor, okay, then there can be some error in sensor which goes to read some which goes to read incorrect data, right? So there may be we can see Tokyo has Paris has -20 around -10 to 10, right? The temperatures, and because of error in sensor, it can show 50 degrees in somewhere. Like I'm just considering, like I'm just telling that it can be possibility, right? So there are lots of possibilities through which a data can be corrupted, or there can be some kind of data which is not useful as well. While considering, okay, we cannot predict that Paris will have 50 degrees. There must be some error in sensing or storing data, right? So such kind of data has to be removed before giving it to a machine learning model. So we cannot directly give all the things and computer will do. Okay, computer, see, when we think of AI and ML and all, what we think is computer has superpowers, okay, and it can do all the things by itself. But no, it is not true. Missing values, error numbers. Yeah, there can be missing values as well. On some day, the sensor was not working, and on that date, the values were not recorded, right? So there can be missing values as well. So what I was telling, so we cannot we have might be, I don't know about you guys, but most of people who are not actually in the tech, what they think is machine learning and AI is we can machine can already do, and we have seen movies like Terminator and all, right? So we are not currently at that stage, but what computer requires, what machine learning is, yeah, we can you have seen multiple things in sci-fi, but those are not true today. That can be possible in future, who knows? But what a computer needs is, it still needs human interactivity. when we are creating a model, or we are before training and all, we people are needed for making the model. See, if you have meet any if you have meet any data scientist and any other machine learning, they will tell you that 80 to 90% of the time goes into data clearing. Okay, clearing data and analyzing the data, removing, cleaning data. Okay, all those this is the main thing that a machine learning scientist or machine learning engineer or data scientist does. Okay, machine learning model cannot be made directly. It requires ML engineers to work on the data, and simply it just needs the correct data. Okay, if we expect machines to work perfectly or work according to our requirement, it needs to have the good data. We call it good data, which does not contain this kind of misinformation or lack of information. Okay, so there is a lot of requirement of data, analyzing data, cleaning data, and all those stuff. So Pandas is very useful in this. We can analyze the data. We can see there can be here we have 6 to 7 lines, but there can be a number of lines. I think it is restoring. I'm sorry. The internet, I think, disconnected. Okay. You can hear my voice, right? Am I audible? I cannot see chat now, so you can unmute and speak. Yeah. Okay. Okay, sure. Okay, I will continue. What I was telling, there can be there are much requirement of dealing with data. So Pandas is very useful tool for that, and Panda facilitates us to see any piece of data. There can be a huge volume of data, right? So this table can be very huge. So if we want to see some specific things in table, or if we see something collectively, then it helps us to do those things. Okay. So now we will do see how we can actually use those things, how we can use functions of Pandas, and how we can use data frames. Okay. So let me share my screen again. It was disconnected. Just a moment, guys. Is my screen visible?
Yeah, we can see the screen.
Okay, all right. So I have downloaded a data set. So now what we will do is most of the time what you will be dealing with is reading those data. You will have most of the time you will have data sets. Okay, most of the time, and when you have to make those data what do we say? Okay, let's start with very basics. Okay, data frame. Then I think it would be more clear, and it would be helpful for you for later on, because I don't want to skip any part of this. So okay, we will created series. Okay, similarly we can create a data frame as well. Okay, let's see my data equals pd dot. I will use the same dictionary. Okay, data frame. Remember this syntax that here we are using this keyword for data frame, as we are using series for here, and remember this capitalization camel format. We can say the D and F are capital, and there is my dictionary. Okay. So what it will do is we can create data frames through many different ways. The most what we can say, the most easy way is from creating from dictionary. Why? Because it has keys and values. So what it does is it uses these keys to name it name the columns. Like if we have name Smith and this roll number, so it will use it as a column name. Okay, just a moment. I think there is some issue if using all scalar values. You must pass. Just a moment, guys. Let's you must pass an index. Okay, all right. So what the error is specifying is that I have used name num. Okay, then Smith and roll number 1. Okay, so it is requiring me to specify an index value. Okay, because I haven't used I have only used single values. Okay, and I will see. Sorry, we will see how that different ways of declaring this data frame is. Just let me resolve this. There are multiple ways we can do this. X equals. Okay, we haven't done this. Okay, all right. R number. Just a moment, guys. It is requiring us to specify the index because we haven't specified any kind of like as I mentioned, it should be homogeneous, right? So it doesn't know that this values will be homogeneous or what should be the index. I had to look it once again. Like we will see. We can use another example for simplicity. Just see data frame data equals pd dot data frame and what we can pass is okay my dictionary. Just a moment, it's connecting. I think it should work properly. It is reconnecting. We will see if it still shows the error. Then we will use another example. Okay. Until it is reconnecting, I think my screen is not frozen, right? You can see it moving.
The screen is a little bit laggy for me.
Okay. I think there is some network issue a little bit. It is showing me connecting. Okay, we will wait for 1 minute. Why is it doing this? Automatic save failed. This file was executed. Just a moment, please. Yeah, it's working fine, but
yeah, I think it is. The screen has started moving right now.
Yeah, but it is connecting with the cloud. I think initializing now. Yeah, now it's working. Just a moment. Connected. Okay. So it should create a data frame for us. Let's see. It's still running. Why it is taking so much time? think there is I think the internet might be slow, or let's do some other stuff until it gets ready. Okay. Yeah. Another way of creating data frame is by using list. Okay. So let's see like names. Okay, names. We have bunch of names here. Name. Tushar. Then Akash. Okay. We have these three names, and then what we have is okay. Yeah. Instead of using names, all right, no problem here. And then another value is we are having salaries. Let's consider salary. Okay, equals 1,000. Just for an example. Okay, 3,500 and 2,000. Okay. So what we are having two lists, and one is names, one is containing names, another one is containing salary. And what we want to do is we want to create a data frame which is having name and salary. Okay, and it should have a name is columns, right? Column names. Okay, data frame salary. Name, comma, salary. So it should do like this. We should do like this. We should pass a list. We specify name, comma, salary. And equals, yeah, we should do like this. Yeah. So here what we are doing is, I don't know why it is taking so much time. I should pause it. Okay. Delete this cell. Okay. So what we are doing is we are using two lists. Okay. And here we are creating a data frame. We are not passing any values now. Okay. What we are doing here is we are just specifying the column name. Okay. The column name should be containing name and salary. Okay. So first it will create empty data frame, and then we can pass name and salary. Okay. So if we print data, it should show us name and salary, empty data frame. Okay. Okay. It directly assigned it. So I think we should use this name, salary. And we can directly import as well if we already have any file. Like these things we generally do not do, because like while creating a machine learning model, most of the time, like someone else is creating data sets, and we can also create data sets. And generally, while as a like machine learning engineer, we do not do that. We are provided with data sets, so generally we do not do that. We just spend our time cleaning and all that. Okay, so now it should work. There is a mistake. Okay.
Syntax.
Yeah, syntax error. It was I think it's already 8. So we should just see how we create database, and then we can continue from tomorrow. Yeah, created successfully, and yeah, now we have populated this. Okay. So what we are doing here is we are it by default what it does is we are passing it name. It stores the name as a data, and then the second argument it uses as an index. It is using it as index. But if we are not doing this, then it will only store names, and we can specify index later. Let's see, data equals pd dot data frame, and just we are giving name. Okay, it should it should use the default index like 0, 1, and then we can add another columns later on. I don't know why it's like slow today. Maybe because of this Pandas library. And why is the salary column being printed before name column? Yeah, as I mentioned that the first argument was used as data, and the second argument was used as the index values. So it was showing the index column in the shell, and that's why it was the salary was being printed before that. The first column, like it is not the column data, but the first column it will show the index values first. Okay, then data. Okay, and sorry guys, just bear with me. Today I think internet is little slow. That's why it is taking so much time. Yeah, as you can see now that these are the default 0, 1, 2 are now it is using default index. Before it was using salary, right? So this is 0. I think the screen is not visible.
The screen is stopped, yeah.
Huh?
The screen is no longer visible, yeah.
Can you see the screen? No, no. Screen is stopped. I'm like it is showing me internet error. Just a moment. Or like it's fine if you take 4 or 5 minutes more, or should we continue tomorrow because it's already 8:06. If you want, you can stay back for 5 minutes. I will show you how like this error. I don't know why today it is happening problem again and again. It happened second time. You can reply in chat box. You can continue tomorrow if need this. Yeah, it's I think it's little slow today. That's why it's causing problem. Yeah. Okay. Can continue tomorrow. I think it's again loading for me from my side. If you want, we can continue tomorrow. So, what do you think, guys? Is everyone okay with that? We can directly start from data frame from tomorrow. Okay. Yeah. Okay. So then, thank you very much, guys, for bearing with me today. I'm really sorry for this internet issues, and yeah, you can enjoy your day. And yeah, please try to practice this stuff, right? Because only doing one time, you will definitely forget this thing. Okay. Yeah. Thank you. Thank you very much. Thank you, guys. You can leave. Thanks for the session. All right. Thank you, guys.